Hey guys, so we are starting quadratic applications and solving quadratics. So I just kind of want to go over some keywords that you're going to have. Vertex is the maximum point or the minimum point that you have. Basically, it's just the highest point on your parabola or the lowest point on your parabola. You have your y-intercept. That's typically how high off your object is going to start. Zeros, those are another way of saying x-intercepts. So x-intercepts have several different ways of identifying them. They could be called zeros, they could be called roots, they could be called x-intercepts, or they could just say, what's the solution for this quadratic? And you're going to have to find that x-intercept. Today we're going to look at solving a quadratic. So the very first thing that you need to do is set your quadratic equal to 0. In example 1 and 2, they've already factored them for us and they've set them equal to 0. So once you get to this form right here, you've just got to set each individual factor equal to 0 and solve it. So if I set x plus 4 equal to 0 and solve, I would need to subtract 4 from both sides to get x all by itself, and x is equal to -4. I would do the same thing with my second factor. I would say x minus 7 equals 0. I have to do the opposite of a -7, which would be to add 7. So x is equal to 7. All right, so your two answers would be x equals -4 and x equals 7. Same with over here, I would set 2x plus 3 equal to 0, and I would solve it for x. I've got to get rid of that add 3. I got to do the opposite, which would be to subtract 3 from both sides. What I do to one side, I have to do to the other. So that gives me 2x equals -3. And then my last step would be divide both sides by 2. So x is equal to -3 over 2. So that is one of your answers. The second answer comes when you set 3x minus 5 equal to 0 and solve it. So the opposite of -5 would be to add 5 to both sides. So 3x is equal to 5. The 3 and the x are side by side. Nothing's in between them, so that's multiplication. The opposite of multiplication would be division. So x is equal to 5 over 3. That is your second answer. All right, so your solutions are your x-intercept. So if you graphed that, your parabola would be crossing over that x-axis at -4 and 7, or at -3/2 and 5/3. Okay. Now, if they give you it not in factored form, that's going to be the first thing that you have to do. You want to factor those. So I would set x squared minus 6x minus 16 equal to 0. And I would factor that. My a is 1 in this case, so I can go straight to a times c. That add to b. 1 times -16 gives me -16. It's got to add to -6. So remember, Desmos does this for you. Do -16 divided by x, -6 minus x in your Desmos. Look for the intersection and you get -8 and 2. So I have -8 and 2. So in this case, I don't need the box. I just need to write my factors. They are x minus 8 and x plus 2. They're equal to 0. In order to find those x-intercepts, I'm setting each individual factor equal to 0 and solving. So I would need to add 8 to both sides, and I get x equals 8. I need to set x plus 2 equal to 0. I would want to subtract 2 from both sides, and I get x is equal to -2. So if you graphed this, your two x-intercepts would be at -2 and at 8 over here. And it would probably look something like this. If you look at that next one, notice that the 3x squared minus 8x minus 16, your a is bigger than 1. So I would need to have the x and the box. The x is still going to be a times c, so 3 times -16. 3 times -16 gives me a -48. It's got to add to -8. So in Desmos, I would do -48 divided by x, -8 minus x, and see where my intersection is. And I get -12 and 4. So now that I have my x, I can move to my box. Remember, the box, the first box is the first term of your problem. So I would say 3x squared. The last box is my last term of my problem. So I would say -16. And then the second two that we have to fill in are going to be our two factors. So I'm going to say a -12x and a 4x. So remember, you're taking the GCF of each row and each column. So if I look at this first row, the GCF of 3 and 12. I can do this in Desmos. I can just say GCF 3, 12, and it tells me that it is 3. Now, your letters also have a GCF. It's just the smallest number of x's that you have. So notice that second box of this row just has one x, so I can only take one x out. Now, if I go to the next row, 4x and -16, if I plugged this into Desmos, they would tell me that my GCF is 4. I can take no x's out because 16 doesn't have any x's with it. Now I need to do the column. So if I do 3x squared and 4x, the GCF of 3 and 4 would be 1. The smallest number of x's that I have is just 1x, so I can take 1x and put it on top. Now remember, as you read from left to right or top to bottom, if your first box is a negative, you need to put a negative out on top. So since -12 was my first box, I need to put a negative. The GCF between 12 and 16 would be 4. So my factors would be 3x plus 4 and x minus 4. Now we're setting these equal to 0 and solving them. So I need to say 3x plus 4 equals 0 and solve. So I would subtract 4 from both sides and divide by 3. So x is equal to -4/3. I also need to set x minus 4 equal to 0 and solve. So if I do x minus 4 equal to 0, I would have to add 4 to both sides, and I would get x is equal to 4. And that would be my second answer. So with my graph, it's going to cross the x-axis at -4/3, which is about -1.3, and it's going to cross it at 4. And it could look like that. Okay? If your equation is not set equal to 0, you have to move everything over before you start factoring. So what I would do with that very first one, I would add 5 to both sides. And I would get x squared minus 11x, 19 plus 5 gives me 24. And now it's equal to 0, so I can solve this. So I would use my x, I would do my a times my c that add to b. A times c would be 1 times 24, which gives me 24. It's got to add to negative 11. So if I do 24 divided by x, negative 11 minus x, I get negative 8 and negative 3. So my factors would be x minus 8 and x minus 3 equals 0. Set each individual factor equal to 0 and solve. So I would have to add 8 to both sides. X equals 8. I would have to set x minus 3 equal to 0 and solve. I would add 3 to both sides and get x equals 3. So those would be my two x-intercepts as my answers. Okay? Now, Desmos can do this for you if you would like to. You have to still set it equal to 0. So I would, in this case, need to add 30 to both sides. So that would give me 5x squared minus 44x plus 150 equals 11x. It's still not set equal to 0. In order to cancel an 11x, I would need to subtract 11 from both sides. So that would give me 5x squared minus 55x plus 150 equals 0. At that point, I can plug that into Desmos. I would just say 5x squared minus 55x plus 150. And you can look at those x-intercepts, click on them. My answers would be 5 and 6. Okay, so if you're solving them with Desmos, you would set them equal to 0 first and then just plug in your function. So for this one, I would want to add 15 to both sides. Remember combining like terms. I can only combine with something that is like. So in this case, I would just say x squared plus 8x plus 15 equals 0. And then you can plug that into Desmos. Look at your two x-intercepts. They're negative 5 and negative 3. So x is equal to negative 5 and x is equal to